kinetic energy. அது மாதிரி தான் இருக்கும். Pre-recorded will be like that, but it will save time for you.
Good evening, sir.
Yeah, good evening, ma'am. Holiday was Saturday. Okay, ஒரே நிமிஷம். Physics பார்த்துக்கலாம். It's easy only. And go through the videos which I told. Those are even அதுலயும் நான் வந்து டீப்பா தான் எக்ஸ்பிளைன் பண்ணியிருக்கேன். Okay. Just remind me, no? After I told her, remind me after the class. No, I can't. You just, I'm planning to place a book there. அதில் கன்சர்ன்ஸ்லாம் எழுதி வச்சுட்டு போனீங்கன்னா I will have a next day I'll take a decision. Because I need to discuss with my team also who's available. Invigilation தேவை. இங்கே நீ எழுதுறப்ப யார் தருவா பேப்பர்லாம்? Yeah. Those who are online are you able to hear?
Yes, sir.
Sir.
Are you able to see my screen?
Yes, sir.
Yeah. You have any doubts, you can ask after this. Relax, Adam. In physics class, I could see some sleepy faces. That's why I gave you some time. Today, தூங்குறீங்க. Last period தூக்கம் வந்ததா? அதனால அதே கனெக்ஷனா? Right. Next nightmare chapter. Only nightmares. போச்சா? ஆடா பாரு. Very good. There also power. எல்லா இடத்துலயும் power cut. There also அங்கேயும் power cut ஆயிரும். 1 minute. Everywhere it's so. Is there a possibility you can set the middle line? Power cuts, sir. Right. I'm not sure if you can see also, but okay. ஒன்னும் தெரியல. Okay, discuss பண்ணலாம். You have book. You have your textbook, right? Okay. We'll see how oral class, podcast class எப்படி work ஆகுதுன்னு பார்க்கலாம். Only voice தான். No video. சொல்றா. எதுப்பா? போனா. Right. So what shall we do? The important chapter. Guys, those who are online, one good news, power cutting. Good news for these people sitting here. Huh? Bad news for me and you. ஆர்வமா உட்காந்துருக்காங்க. Full energy they have come and sat and அப்படியே டபால் பத்தியா. Okay. So எனக்கு என்ன பண்றதுன்னு தெரியல. When I'm thinking what to do. Can we do some, can you guys do the remaining problems of inverse trigonometry? The 3 or 4 problems are there, no? Can you just do them quickly?
Okay, sir.
I'll give you hints. I'm expecting the power back in 10 minutes, hopefully. இது ஏதா ட்ரிப் ஆச்சா? பாஸ்கர் ட்ரிப் ஆச்சான்னு பாத்தியா ஏதாவது? ஏதா ட்ரிப் ஆச்சா? How many problems are over? So what was the last problem that we did yesterday? Sorry? 8, no. Okay, how many more are there? 6, okay. So do the 9th one, no? So 9th one, what is the hint? Trip acha. என்ன மாச்சு? ஏன் அவ்வளவு எமோஷன்? சொல்லு. The electric flux is inclined. Field lines. But we generally take acute only. That is, we take it in the direction of electric. That is for a 2-dimensional surface, but it's not the same for 3-dimensional. But we generally take it in the direction of electric field because we say we take it from the right. See, for example, the electric field lines are to the right. We take it to the right to say that the number of field lines are coming out of the surface. If you take negative, you say that they are entering. If you're going to be positive, you're going to say it is coming out of the surface. But it is depending on the orientation. So plus Plus sign indicates that the electric flux is out of the surface. Outward, no? Field lines are coming out of the surface now. If there is a box, for example, this room is there, let's say electric field, imagine the rays of sun that is coming in. So the rays of sun that is entering this is considered to be negative because the rays are in this direction, aerial vector is in the opposite direction. So we're just giving a sign convention. So the negative there indicates that it is entering and positive indicates that it is leaving. Direction is defined for a vector quantity. Sign convention is defined for having a particular value. See, for example, 1 by v plus 1 by u is 1 by f. You take v as negative and it is on the left hand side. It's not a vector quantity, you know. For us, for a universal conversation, that's it. Yeah. Which problem? Physics category, max category. I shut down my brain for physics. Next is repeat. Physics class. Meeting ID and password. So, what is the question? What is the ninth question? Technology. Current the you have your phones, sir. You have your phones. Can you log into your phone? But put it on mute. Don't join the audio. You have? You don't have. Okay. So you have? How many of you have your phone now? But how will you share? So you both can. You don't have phone, Ada? You both will share. What about you three? You have, Ada? Can you put it in the center? Okay, you three can share. You have to come to the center. You three share. You can see it from here, Mama. Then it's fine. So those who don't have phone, come front. You can see from here. Those are online. You are able to hear, right?
Yes,
Yes,
sir.
sir.
Okay, perfect.
Yes, sir.
So tell me, what is the? Hey, you guys can come. You're sharing, huh? Okay. So what is the ninth question? Can you tell me? Cot inverse of root of 1 plus sin x plus root of the whole divided by root of 1 plus x minus root of 1 minus sin x is equal to x by 2. We need to prove this, right? So I've already given you the hint of how to solve this. So wherever you have 1 plus sin x, what are we supposed to do? So 1 plus sin x is written as cos square x by 2 plus sin square x by 2 plus 2 sin x by 2 cos x by 2. So what will it give you? It will give you cos x by 2 plus sin x by 2 the whole square. Am I right? Okay. So cos x by 2 plus sin x by 2 the whole square is what you're going to get. Right? Similarly, what will 1 minus sin x be? Cos x by 2 minus sin x by 2 the whole square. Am I right? So what will happen to the question? It is cot inverse of root of 1 plus sin x will be cos x by 2 plus sin x by 2 the whole square under a root. So what will you get? Cos x by 2 plus sin x by 2, right? Plus root of 1 minus sin x is cos x by 2 minus sin x by 2 the whole square. So which is under a root. What will you get? Cos x by 2 minus sin x by 2 the whole divided by, what will you get here? Again cos x by 2 plus sin x by 2 minus of cos x by 2 minus sin x by 2. So what will get cancelled in the numerator? Sin x by 2 is lost in the numerator. Cos x by 2 is lost in the denominator. So what are you left out with? Cot inverse of cos x by 2 divided by, 2 cos x by 2 divided by, very good. So 2 and 2 will get cancelled, which implies it will be cot inverse of cot x by 2, which will be x by 2. That's what we are asking. Right? Easier. Answer conjugate money the differential function. Clear with this?
Yes, sir.
So did you all copy it? So what is the 10th problem? Yes, sir. Triple inverter. Keep off on the button, switch off. On the switch off. 10th, what is the question? Tan inverse of root of 1 plus x. Soluma. Oh. So root of 1 plus x by minus root of 1 minus x divided by root of 1 plus x minus, correct? Sorry, 1 is equal to pi by 4 minus half of cos inverse of x. Right. What are we supposed to do here? This problem. See, whenever they ask you to prove, right, first thing is you always look at the right hand side. So right hand side, what is the trigonometric function that we have? Cos inverse x. But you have a prefix to it. Like there is a multiplication factor to that cos inverse x. Half. So what you need to do is always do this kind of a rough work. Half of cos inverse x, if I take it to be theta, then you will substitute x is equal to cos 2 theta. Am I clear with this? Did you understand what I did? Half of cos inverse x, I equated to theta. So 2 will go to the other side, it becomes 2 theta. So cos inverse x is 2 theta means x is cos 2 theta. So wherever, that is what you're supposed to substitute, wherever you see x on the left hand side. Right? Solve them. So what will you have? Tan inverse of root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta divided by root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta. So what is 1 plus cos 2 theta? 1 plus cos 2 theta. 2. It is 2 cos square theta. See, everybody listen. Okay. There are two kinds of scenarios you will find. One is 1 plus cos of something, or you'll find 1 plus sine of something. The reason why I'm using something is that something can either be x, 2x, 3x, 4x, whatever it is. Okay. But if you find the sum of, that is sine getting added to 1 or sine getting subtracted from 1, you should think of the previous idea which I gave you. That is cos square x by 2 plus sine square x by 2 plus 2 sine x by 2 cos x by 2. Okay. Whereas if you have 1 plus cos of something, you need to start thinking in terms of cos to theta formula. So what is the formula for cos to theta? Cos square theta minus sine square theta. That is one. The second, it has 3 formulae. What are they? Cos square theta minus sine square theta. Second, 1 minus 2 sine square theta, or 2 cos square theta minus 1. So when I write it as 2 cos square theta minus 1, when this minus 1 comes to the left hand side, it will become 1 plus cos 2 theta. So what is going to be the formula? 1 plus cos 2 theta is 2 cos square theta. That is the reason why we write it as 2 cos square theta. Am I clear? Similarly, cos 2 theta can also be written as 1 minus 2 sin square theta. So if I take cos 2 theta to the right and 2 sin square theta to the left, then what will you get? 1 minus cos 2 theta is 2 sin square theta. Are we having both these in this question? You have 1 plus cos 2 theta and 1 minus cos 2 theta. So it's direct formula. So tan inverse of, what is 1 plus cos 2 theta? 2 cos square theta, which is under a root. Then what will happen? Root 2, you will have root 2 cos theta minus 1 minus cos 2 theta, root 2 sin theta divided by, this will be root 2 cos theta minus root 2. How come minus in the numerator and denominator? Did I copy the question wrong? Where is plus? Denominator is plus, sir. Now it's fine. Am I clear with this? Is everyone clear? Yeah. So tan inverse of, the root 2 will get cancelled in the numerator and denominator. So what is that you will be left out with? Cos theta minus sin theta divided by cos theta plus sin theta. So what you should do is multiply, divide the numerator with cos theta. So what will you get? Tan inverse of 1 minus tan theta divided by 1 plus tan theta. So what will you have at the end? Tan inverse of tan of pi by 4 minus theta. So tan inverse of tan of pi by 4 minus theta. Where? Root 2 cos theta. Root 2 is cancelled. No, take root 2 common, the numerator and denominator. So, am I clear with this stage? So you are left out with tan inverse of tan of pi by 4 minus theta. So this will be pi by 4 minus theta. But what is theta? Cos 2 theta is equal to x. So 2 theta is equal to cos inverse x. Theta will be half of cos inverse x. So substitute it here. That's what the answer is. Did you understand that? Now try to do it on your own. Those are online? Are you able to hear?
Yes, sir.
Yes, sir.
Good. Then 1 minus tan theta by 1 plus tan theta is tan of pi by 4 minus. See, it's very simple. 1 minus tan theta by 1 plus tan theta. Look at the way I'm going to write. In this place 1, I'll write it as tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 tan theta. So tan A minus tan B by 1 plus tan A tan B is tan of A minus 1. That is why tan of pi by 4. Okay. I hope it is clear, no?
Yes, sir.
Good. So what is the next one? நீங்க எப்படி சொல்லி தரது? I have downloaded one app also to show you, but I'll partner will understand it better. Unfortunately, it will work. And you have only 20 minutes. You need continuity alone. Understand? Okay. The remaining problem, then you do. But is everyone equipped with a phone that you are able to see? Because this chapter is very important. If at all I start continuity, will you be able to handle it? Like, not even. You both alone don't have phone, right? Not even. And do you have your textbook? Is it blocking you? Can you Nisa, can you move this side? Ashwin, the share and give it to London. Right. So, for safer side, you can have your textbook open. I don't know the page number. Which page number is this? Continuity and differentiability. 114. Okay. So those are online also. You can have your textbooks open. 104. Listen. There is no change in it. But all you have old textbook, it is in page 147. Okay. So let me give you the outline of what this chapter is. Can you tell me what was the name of the first chapter that we discussed? Okay. What was the objective of the chapter? What did we try to understand? So we understood, see, from basically, if a data is given in the form of some arrangement, which we call it as set, with the Cartesian product, based on which we got the ordered pairs, right? So when it came to the concept of relations, from that ordered pair set, we chose the elements, or we chose the ordered pairs which were satisfying the condition which we wanted. Based on them, we call them as relations. But to those relations, if you put a specific condition, then it becomes a function. What is the condition that you put? When will a relation become a function? When all the elements from set A are associated with only one element in set A. If it crosses more than that, it becomes a relation, but it's not a function. Okay, so there we understood what a function is. Apart from that, if you combine the knowledge of your 11th standard and 12th standard, right, they both are actually important. When you see your 11th standard concept, you would have learned the kind of functions like identity function, the polynomial function, then you had trigonometric function, you had different types of functions. When it came to the 12th standard part, you learned the same types of functions. The heading was the same, but the concept was completely different. What were the kinds of functions we learned? One function.
One function, many to one.
Onto function and bijective. So the combination of both, right? So among all these three, each function has its own importance. Am I right? Why were those two important? Why was a bijective function even important for us to understand? To understand how does an inverse exist, or else you would have never had a branch of mathematics called as inverse trigonometric functions, right? But here comes another important question. If at all I give you a function, there are other types also, like you have something called as an even function, you have something called as an odd function. All those things are there, which are again needed for calculus, right? So now another important job that we are going to get is, if at all I give you a function and I ask you to plot the equation on a graph sheet, right? Here all we are doing is drawing a rough graph. If at all I ask you to take the real points and then plot it on a graph sheet, you will definitely obtain one shape, right? So when you obtain those shapes, there is a possibility depending on the domain of that function where it can be defined at a particular point or not. For example, if I have a question, sin x, y is equal to sin x. So the first thing that we need to answer is, what is the domain of this function? I told you, right? We need to stress on these points. What is the domain of this function? X belongs to R. What is the range of this function? Y belongs to, simple, all the values of X is the domain, all the values of Y is going to be the range. That's it, right? By now we understood this concept. Now, if I take the same function but in a reciprocal manner, 1 by sin x is not the same as sin inverse x. I hope by now you would have understood. Inverse is different from reciprocal. So 1 by sin x is basically cosecant x. So the same function, when I bring it to denominator, it is creating a restriction on the domain. Is it doing or not? So how does it do? If I take x belongs to, you can substitute any value except the place where sin x will generate a 0. So you can substitute any real number except those values where sin x will generate a 0. Where will sin x generate 0? It will generate at n pi. That is a general solution of it. If I'm not wrong, that was also derivative, right? Trigonometric equations. So it's, this n pi is called as the general solution of the trigonometric equation sin x is equal to 0. Am I clear to this point? Right. So what I'm going to do is, if I plot the sin x on the graph sheet, then I'll get a shape like this. Am I right? Okay. But before that, what is the range of cosecant x? Y belongs to? You will obtain all the values between minus infinity to minus 1 union 1 to infinity. So the first graph that I drew is a graph for sin x. Right? If I draw the graph for cosecant x, how is it going to be? Cosecant 0 is going to lead to infinity, and cosecant pi by 2 is going to lead you to 1. Means it is going to come like this, and it is going to go in this way. So when I draw a line here, this is going to be 0. At 0, it will never touch the y-axis. At pi, it will never touch the y-axis. Again, so this is pi. After this, what is going to happen? So basically, I'm not doing anything except observing what is happening in one complete cycle. When I say one complete cycle, it is between 0 to pi, half cycle. Pi to 2 pi is another half cycle. Means I'm breaking the 4 quadrants into 2 parts. The top 2 quadrants, which is the first and the second, the bottom 2, which is the third and the fourth. That's how I'm thinking. Okay. So here, if I observe, the graph is going to look like this. So when I draw these dotted lines, I'm trying to say that the graph is not touching the, is not having a finite value at that particular value of input. At which value? At pi, 2 pi, 0, all these places does not have. Right. So this is speaking in terms of the domain and function. Now, what does this have to do with the continuity and differentiability? Right. So what I'm going to do is, if I observe sin x graph, the graph itself is telling me that this function is continuous. Meaning, if you look at the basic point of it, the graph does not have a break at any point. Whereas if you see cosecant x, is it having a break at a particular point? Where? So it is having a break at pi 0, pi 2 pi. Similarly, on the left hand side, minus pi, minus 2 pi. Everywhere it will have a break. So the place where it is having a break, the function is said to be discontinuous. Okay. So this is a graph that we could draw it, because cosecant x graph we are used to it. We have seen it many times. You need not even think of what it is. You'll just put U shapes and draw it. But what if I complicate this function by making it a square root of cosecant x or square root of sin x? It will become difficult for us. So at that time, we definitely need a tool in our hand to understand whether this function is continuous or not. Because here what we did is, we actually understood the continuity of the function with the help of graph. But the reverse is also possible. Means if I give you a tool and ask you to find out whether this function is continuous or not, that will help you to draw the graph also. So for that, the tool that we are going to use is limits. So what is it? We are going to use limits. So basically, the concept is very simple. Continuity and differentiability is an extension of your last year's concept of limits and derivatives. Okay. So when it comes to the value of limits, there are three things which we need to know. Listen to this carefully. One is left limit, second is right limit, and the third one is function value. Right? When I say, see, I just told left limit, right limit, and function value. This statement does not make sense unless I add a word called as, or unless I add a point called as left limit, right limit, or function value at a given point. Meaning, if you take the sin x, right, y is equal to sin x is there. In the domain, how many points are there? You say x belongs to R. So how many points are there along the x-axis for which this function is defined? Infinite. All the points, minus infinity to infinity, you have infinite number of points. At all those infinite points, the sin x is trying to be continuous, means it's not trying to break anything. So whether you approach from the right hand side, meaning visualize it like this. I can draw the graph like this. So when I draw the graph like this, I'm approaching the points from left to right. But if I know this graph very well, I could have drawn it like this also. I would have done that. It's my wish. So I'll draw it like this, meaning I'm approaching the same point from right hand side. So from left side or right side, let's say you are approaching a particular point, you will check how the limit of that point is going to be. If the limit from the left hand side, right hand side is exactly matching with the function value, then that kind of a function is said to be continuous. Okay, so when I talk about limits, what are they? One is left limit, one is right limit, and the third one is function value. If the left limit comes out to be equal to the right limit, comes out to be equal to the function value, then the function is said to be continuous at that point. So you should say you can continuous at some x is equal to some c, which is a random point, and that c should be a part of the domain. C cannot be a part. See, for example, this pi is there no for cosecant x. That is not a part of the domain. It is discontinuous at the point which is not a part of the domain. Okay. So left limit, right limit, and function value at x is equal to c defines the continuity of that particular function. Now you can ask me a question. There will be certain scenarios. This is not there in your textbook. I'm just telling you, listen to this question. Sometimes what will happen is you will approach a particular point from the left hand side. You will approach the point from the left hand side. Sometimes left limit will be equal to the function value, but that will not be equal to the right limit. You can have that kind of a scenario. Similarly, left limit will not be equal to the function value, but that will be equal to the right limit. So what do you call these kind of functions? Are they continuous or discontinuous?
It is not continuous.
It is not continuous. So these are discontinuous, but the other way of defining it is this one. The first one that I wrote is discontinuous from the right hand side. So it's called as a right. It's called as left continuous or right discontinuous. So it's continuous from the left hand side, but not continuous from the right hand side. Similarly, for the second scenario, what will I do? It's called right continuous, but left discontinuous. Right, it's basic, simple language only. Continuity has nothing to do. Whether the graph is breaking at a point or not, that's what we need to do. So, what is the tool that we are going to use? Limits. Right. So, to apply these limits also, there is a specific method in which you can do it. So, based on this, there is one theorem given in your textbook. Look at the definition one, which is given in your textbook. There is a definition one. If you have a real valued function f, then it is said to be continuous at a point C in its domain, provided limit extends to C, f of x comes out to be equal to f of C. Right? If this happens, you can say that the function is continuous. But why did I speak about left limit and right limit? Not necessary, no. So by them saying that limit extends to C, f of x is equal to f of C, this statement itself is covering the left limit and right limit within itself. It is covering both the values within itself. Okay. Now, just to recollect, if at all I take a point C, then how do you calculate the left limit at point S? It is something like this. Limit x tends to C, and you'll put a superscript minus here. Right? It is C minus f of x is equal to, what you will do is limit, you will change this as, you will change it to some other variable which is called as h. Limit h tends to 0, f of C minus h, and solve this. So when you solve this, you will get a value. You will get a number. Okay. Similarly, for right limit, what are we supposed to do? Limit x tends to, by now you would have understood, C plus, you write f of x is equal to limit h tends to 0, f of C plus h. C plus h means I'm approaching from the right hand side. So solve this, you will get another value. If the left limit value and the right limit value are matching, the next step that you are supposed to do is check the function value. If all these three come out to be the same number, then there are two languages you can state it. You will either say limit exists. That's what you would have learned in your 11th grade. Limit exists also means that the function is continuous at that point. That's the language of 12th standard. Both are same. Right. So last year you actually learned how to use this tool. This year we are actually applying. Am I clear with this? Okay. So what is the meaning of this is, if at all I have a random function like this and I have a point C, right? I'll consider one point on the left of it which is at a distance h. So what will this point be? C minus h. I'll consider a point on the right hand side which is at the same distance h. Then what will this point be? It will be C plus h. Right? So this point is f of C minus h. Actually it is C minus h comma f of C minus h. C minus h is the x coordinate, f of C minus h is the y coordinate. Similarly, what will be the x coordinate and y coordinate here? C plus h comma f of C plus h. What will this point be? I'll use another color. What will this green color point be? This is C comma f of C. So what we are actually doing is, you're taking that, I wrote that f of C plus h. No, f of C plus h means this point. So in that f of C plus h, if h is tending to 0, where should it reach? Simply, if I put h is equal to 0 and f of C plus h, what will you get? The f of C plus h is there. If I put h is equal to 0 here, what will I get? F of C. That is what you're doing. Means you're approaching that point C from the right hand side. That's why it's called as right limit. Similarly, f of C minus h is, if I put h is equal to 0, again I'm going to get f of C only. Right? So this is where the challenge starts. Sometimes what will happen is, when you're approaching from the left hand side, it is not always necessary that the function value will go to f of C only. Sometimes it will go to some other value. Okay, that is where we can create the difference. See, for example, I'll just do the example and show. You can look at the video later. Okay, see, suppose I take the function y is equal to 2x and I'm checking the continuity of the function at x is equal to 1. According to the definition given in your textbook, if you say limit x tends to 1, f of x is equal to f of 1, it is continuous. But if you go slightly in depth, right, if you check the left limit, how do you write it? Limit x tends to 1 minus f of x. F of x is 2x. So next step is limit h tends to 0. Transfer that x to h tending to 0. What will you write? 2 into, in the place of x, you will write it as c minus h. So what will, c is how much here? C is 1. C is 1. You will write it as 1 minus h. So when you substitute this value here, what will you get? You will get 2. Similarly, for right limit, limit x tends to 1 plus 2x. Okay. Limit h tends to 0. 2 into 1 plus h. So h is equal to 0. It is 2. What is f of 1? F of 1 means take this 1 and directly substitute it here. F of 1 is 2. So what is happening in this case? left limit, right limit, and function value are the same. Hence, this is a continuous function. So this is obviously known. Y is equal to 2x is basically a line passing through the origin. So at x is equal to 1, either from left hand side or right hand side, it is going to be continuous. Okay. Then you can ask me, sir, how is this going to help me to calculate discontinuous function? See, don't worry, I'm repeating it again. For everything, I've already given you videos. You can sit and read at your own pace. This point alone, I'll complete so that the concept will be done. So y is equal to tan x is there. If you take x is equal to pi by 2. What is left limit? Limit x tends to pi by 2 minus. What should I take? Tan x. So how should I shift this to? X should get shifted to h. See, procedure is the same. H tends to 0. Tan of pi by 2 is the value of c. Pattern same, pi by 2 minus h. But the only thing is, here, don't substitute the value of h directly. Tan of pi by 2 minus h is, it is actually cot h. Now substitute the 0. Cot 0 is 1. Sorry, 1 11. How much is it? Cot 0? Cot 0 is infinite. Yeah, infinite, undefined. So it is positive. It goes to the infinite value in the positive direction. Okay. Now, if I take the right limit, Tejas, can you tell me the steps? X tends to pi by 2 plus try panna. Right limit kept here. Limit x tends to pi by 2 plus tan x. What will be the next step? Limit x should be shifted to h tends to 0. Sorry, tan of, in the place of x, what should I write? Pi by 2 plus h. Pi by 2 plus h means which quadrant? Third quadrant means what will happen to this? So third dilemma, second. So it will be minus cot h. It will be minus cot h. If I substitute h tends to 0 here, I'll get minus infinity. Though they are undefined values, this and this do not mean the same. Then what is f of pi by 2? Tan pi by 2 is infinity. So what is happening here is left limit, right limit, function value. Okay, I'll put the function value here. Left limit, function value, right limit. So which two are equal? Left limit is equal to the function value, but not equal to the right limit. So this is an example of discontinuous function. That is why, if you look at the graph of tan x, right, it will be like this. So where is it breaking from? It is breaking from the right hand side. So from the left hand side, it is continuous, but it is breaking from the right hand side. That's why you call it as left continuous function. See, to some extent, are you able to get the idea? Okay. So what I would suggest is, like I have already given the videos for these things, and I've touched upon the basics of 11th standard also. If you have not learned limits and derivatives properly, right, I would suggest you go through them again. The same concepts I would have explained there also. So it will be under the pre-recorded session under chapter 5, continuity and differentiability. Go through these concepts and come so that you will understand things better. Right? So now I couldn't give you time to write it. Okay. But to some extent, I'm assuming you got ideas. Right limit, it's called right continuous. So from whichever side it is continuous, you add the prefix to it.
But it should be
It is not a continuous function, but only from one side. But for the condition to get satisfied of continuity, it should be continuous from both the sides. Am I clear with that? Right. So now you are able to understand why we learned functions in the first place. That is why it is important. Okay. So yes, you can have a look at the videos. You'll understand it better. Those are online, you can wind up, you can leave.
Okay,
Divya,
sir.
Understood.
yeah.
Thank you, sir.
Yeah.